This is a session on the various control structures we have in C programming. The flow of control within a C program happens to be by default sequential. That is, it flows from line number 1 to 2 to 3 and so on, line after line, as we have written in the program. If you want to alter the flow of controls in a C program, what is possible is we can make use of one of the following control structures which are available in C programming. The various other control structures we have in C programming are broadly classified as selection structures and repetition structures. What are selection structures? A block of a code in your program gets selected based upon satisfaction of a particular condition. Examples for that kind of statements are a normal if statement, a if else statement, or a nested if construct. Then we do have another set of constructs which we do call as repetition structures, wherein a set of statements get repeated for a while as long a condition gets satisfied. Examples for that happen to be the for statement, the while statement, or the do while construct. Now let us have a brief visit towards the if statements what we do have in C programming. What is a if statement? It is a condition checked execution where the condition gets checked at the entry step itself. That is, if I do have a condition like if a greater than some 10, the statement gets executed within the block. Otherwise, the control flows to the next statement in the program. That is, I want to check whether a were greater than 10, and if a were going to be greater than 10 and if it were true, the statements within this if block will get executed. If this condition stays false, the statements within this block get ignored and the control flows to the next line. Now, there is no separate statement that gets executed for the condition happening to be false. If I want to still address the false part too, then I can go and land at the if else statement. What is there special with an if else statement? It has a special mention towards the else part also. Here we have dealt with only the true part, but an else statement as like this handles the various statements with regards to the false condition. So now we treat both the true part as well as the false part, wherein we treat every single condition of the condition being either true or false. This is there with your if else construct. The next thing happens to be the nested if else construct. That is, we need to address not only the true or false part, but the different occurrences of a particular event. Then we can address them using an nested if statement. How does it work on? Just have a look. We might have had the grading of marks for different students. The grading of marks for every student gets determined by the number of marks he has scored in a particular subject. For instance, if a student has scored more than 90% of marks, his grade happens to be S. If he had scored anywhere between 80 and 89, his grade happens to be A. If he had scored any marks anywhere between 70 and say 79, his grade happens to be B. Let's just have a look as how your marks get or your grades get allocated. That is, if the mark were greater than or equal to 90, you would say print grade is A. Else, if mark were greater than or equal to say 80, you say print B. Else, if marks were greater than or equal to 70, you say the grade is C. If you look at the flow of controls across this control structure, it will first get into this first if condition where it checks the marks to be greater than 90. If the mark were greater than 90, it simply prints the grade is A. Say for example, if a student has secured marks somewhere between 80 and 89, what happens is this is not satisfied, because of which the control flows into this particular block where the mark gets satisfied for this particular criterion and this gets printed. After having executed this, it won't stay anywhere anytime more in the entire block and it will come out of the entire if else construct. This is termed to be the nested if statement. Now we have gone across the various selection structures we have in C program, that is the if statement, if else statement, and then the nested if statement. Now in this session, let us have a focus on the repetitive structures, that is how to handle a for statement, how to have a while statement, and then how to have a do while statement, at the end of which we will be introducing towards the switch case construct. Now what are the essentials for repetition? What is a group? What is a loop? A loop is a group of instructions where the set of instructions get executed by the computer repeatedly while some condition remains true. This is termed to be a looping structure. I repeat again, a looping structure is a group of instructions that the computer executes repeatedly while a certain condition stays true. These looping control structures are falling into two different categories. One, a control variable controlled sequence and a sentinel controlled repetition. What is a counter controlled repetition? That is, it is a definite repetition which is having a brief knowledge about how long it has to repeat. That is, there is a control variable which is used to count the number of repetitions. The next one happens to be the sentinel controlled repetition. That is, it is an indefinite or an indefinite repetition. This is used when the number of repetitions happens to be unknown. The sentinel values indicate the end of data. Now moving on towards the counter controlled repetition of the statements. What does it do? It needs to have the name for a control variable. We usually used to have for I equals 1, I less than or equal to n, I plus plus, where I is termed to be the control variable. So the control variable should be named. Then what is the initial value of the control variable? Because the set of statements are going to be repeated based upon the counter variable. For that purpose, we need to know where the counter variable starts from. That is what we do call as initial value of the control value. Then the condition that tests for the final value of the control variable, that is, I have some statement like I less than or equal to n, which means that this is the condition check for that counter variable whether it has exhausted the entire loop or not. And finally, we do have an increment or a decrement by which the control variable is modified each time across the entire loop. Then comes an example of a simple for structure where we do have a counter like I initialized as 1, and we do have a statement like for I equals 1, I less than or equal to n, I plus plus. So I have statements A, B and C. These statements A, B and C get executed for a number of times as long as I is less than or equal to this variable n, which is often given a numerical value. Just for a reason of understanding, I have had it as n. It usually becomes something like 30 or 40 or anything as per the program's need. Here we do have three partitions. One, the initialization of the counter. Number two, the condition check of the counter. And then the last happening to be the incremental or decremental value of your counter. These are the three important parts of a for block. It has an initialization, it has a loop continuation test, and at last it has the increment or decrement part of the entire statement. Now we can have a simple for statement that can print values from 1 to 10. For this example, we can have a for statement like for int counter equals 1, counter less than or equal to 10, counter plus plus. A printf statement which prints the counter will count numbers from 1 to 10. This is a simple example of a for statement. For loops can usually be rewritten as while loops. How can a for loop be rewritten as a while loop? The same thing, you can have the initialization outward, then you can have a while condition, then you have the statements to be executed, and within the block you need to have your increments done. Let us have a simple example of how to convert a simple for statement which we had here to look like a while statement. This is the for statement what we have had in our program, that is for I equals 1 where we have initialized I, we have had a condition check like I less than or equal to 30, we have I plus plus, within which we need to execute the statements A, B and C. How can one convert this for statement into a while statement? Make one thing clear, the initialization should be outside the loop, that is you want to initialize it as I equals 1 outside the block. Then comes your keyword of the construct what we call as while. Okay. What goes inside the while? The condition that checks the validity of that entire block. That is, we have some condition like while I less than or equal to 30. Then the same set of statements, say A, B and C get inside that block, which is soon followed by the increment that you give for I. This is how a for statement gets translated as a while statement. Now, this initialization and increment are the most mandatory ones. We need to have one outside the block, the other inside the block. This is how a for statement gets transformed as a normal while statement. There is another kind of a statement what we do call as a do while statement. What is there as a difference as a while statement to a do while statement? A do while statement again has a check like a initialization like I equals 1 where it starts like the do statement where it does statements A, B and C and it has some count for I and then it checks for the condition like I less than or equal to . This is a typical example of a while statement and this stays on to be a small do while statement. In this case of while statement, when the control enters the block itself, it happens to be checked, because of which we do call this as an entry checked one. If at all this condition gets satisfied, it won't execute the statements inside the block. But when you compare a do while block, the control flows into the block for the first time. So for A, B and C to be executed for the first time, it does not require any condition satisfaction. But in case of a while statement, the condition has to be satisfied even for the first run of the set of statements what we have within this block. But in case of a do while block, the first time it gets by default executed and at the end of your first run, it gets your condition checked, because of which we call this to be an entry checked one and this do while block to be an exit checked one. Based upon the necessity of your particular program or application, you can make use of either while block or a do while block. Now, there is the last set of statements what we do call as a switch case statement. What is there with a switch case statement? A switch case statement can also be called as a selection statement rather than a repetition statement. A switch case statement has its construct as like this. This is a typical example of a switch case construct. What is the switch case construct? This is a statement which operates on the case value of your case variable. If the case value happen to be 1, this particular block will get executed, and at the end of this particular block, after having executed, it has a break. Here you need to have more insight towards what a break statement is and what a continue statement is. We need to understand something about two different keywords, what we usually call as break and then continue. Let me first explain you something about break. A break causes an immediate exit from either a for block or a while block or a do while block or a switch structure. The program execution continues with the first statement after the structure. The common uses of break statements are something like escape early from a loop, then skip the remainder of the switch structure. These are the examples where we make use of a break statement. I repeat again, a break causes an immediate exit from either a while block or a for block or a do while block or a switch structure where we make use of it. Number 2, the program execution continues with the first statement after this structure. The common uses of the break statement imply a early exit from the loop where we are, or it may be used to skip the remainder of the switch structure. This is where we do make use of a break statement. Then the important statement happens to be continue. What is a continue statement and in what way is it important? It skips the remaining statements in the body of a while or a for or a do while loop, but it proceeds with the next iteration of the loop. Please note down here that a break statement completely exits the remaining iterations of your entire block, be it a while, a for or a do while, whereas a continue statement just skips that particular iteration and proceeds with the next iterations of the for block or the while block or the do while block where you make use of it. Then the looping continuation test is evaluated immediately after the continue statement is executed. Then for a for structure, increment expression is executed, then the loop continuation test is then evaluated. So this is how continue is done for the different kinds of structures. That is, you can make use of a continue statement in either a do while statement or it can be made use in a for statement. In case of a while or a do while statement, what happens is the loop continuation test is evaluated immediately after the continue statement is executed. In case of a for structure, increment expression is executed, then the loop continuation test is performed, based upon which it either follows on into the loop or it quits out of the entire block. Now let us have a glance at the various switch case constructs. A switch case construct has efficiently these parts, that is, it starts with a keyword switch. Please mind, S over here is a small case letter. Then it checks for a case value. Based upon the case value, it either flows on to any one of your case controls. That is, if this case value were to be 1, it executes this particular block. And please have it in mind that every case value should be broken. If it were not broken by the use of the keyword called break, the control would tend to flow into the remaining parts of your cases, which is not an advisable one. So a switch case is often operating on a case value. Based upon the case value I have here, it moves on towards that particular case. After having that particular case executed, we make a deliberate break out of the switch case construct. If the case value that we have obtained in the program does not match any one of these case values, the control automatically flows on towards the default block where a user can be indicated about the amount of or the nature of the values he has supplied for the switch case. In that case, the new values are obtained from the user and then these case values, which are known to be the prominent ones, will get executed. This is how we make use of a switch case construct.